All right, let's dive into some really cool new research that gets to the heart of one of the biggest puzzles in AI right now.
I mean, we all see it, right? These large language models are unbelievably smart. They can write beautiful poetry, they can debug complex code, they can even ace professional exams. But the moment you ask one to do a serious, high-stakes professional job for more than a day or two, things just kind of start to fall apart. So, what is going on?
So, to figure this out, some researchers took a closer look at a specific field, building specialized web mapping software. WebGIS. This is a field where you absolutely have to be precise and consistent. And when they put an AI on the job, they noticed it wasn't just failing, it was failing in the exact same ways, over and over again. And it turns out these failures weren't random at all. They actually fall into 5 very specific buckets. Think of them as AI's 5 fatal flaws when it comes to doing real professional engineering work.
Okay, so first up, long context limitations. You give it a big project, and by the time it gets to the end, it's already forgotten what it did at the beginning. Then there's cross-session forgetting. It literally can't remember what it learned yesterday. Next, you've got what's called output stochasticity, which is just a fancy way of saying it's completely unpredictable. It also has a really hard time following instructions. It treats a strict rule like it's just a friendly suggestion. And finally, there's adaptation rigidity. It's just so slow to pick up new, project-specific rules.
And this is where the researchers had this huge aha moment. They realized the problem isn't that the AI isn't smart enough. No, the problem is that we're asking it to work without any real management. It's not a capability problem, it's a knowledge governance problem.
So what does that actually mean? Well, just look at this comparison here. The old way of trying to control AI is what you see on the left, informational strategies. Basically, you just give it advice in a prompt. But that advice fades, you can't really check its work, and honestly, the AI can just decide to ignore it. The new approach is structural governance. Here, the rules are enforced. They stick around. They're auditable. Compliance isn't optional. It's really the difference between a helpful post-it note and a mandatory company-wide policy.
So to fix this, the researchers came up with a whole new way to manage an AI agent, and they call it the Dual Helix Governance Framework.
The whole idea is actually borrowed from DNA. You've got these 2 strands that wrap around each other to create a super stable and reliable structure. In this case, one strand is the AI's knowledge, the what, and the other strand is its behavior, the how. And by weaving them together, you make the whole system stable. Let's break that down a bit. The what strand is handled by what's called knowledge externalization. This is basically a permanent memory that lives outside the AI's own brain. It stores all the crucial facts and design patterns for a project. And the how strand? That's behavioral enforcement. This is a set of hard-coded mandatory rules and protocols the AI absolutely must follow. No more suggestions, these are the law.
In practice, they built this using something called a knowledge graph with a 3-track system. Just think of it like this. Track 1 is the knowledge base, right? The project's forever memory. Track 2 is the behavior layer. That's the strict rulebook it has to play by. And track 3, that's where the magic happens. It's where the knowledge and the rules intersect to create what they call skills, which are basically stable, pre-approved ways for the AI to get work done right every single time.
Okay, this all sounds amazing in theory, but does it actually work in the real world? Well, to find out, the researchers gave it the ultimate test. They asked it to fix a really messy but important piece of scientific software. The project was a tool called Future Shorelines, which is super important for predicting sea level rise. The problem, its code was just a mess. A single, tangled-up file with over 2,000 lines of code, what developers call a monolith. The mission for this new governed AI was to untangle that whole thing and rebuild it as a clean, modern system. I mean, this is a job that would take a human developer weeks of headaches. And the results? They were absolutely staggering. First off, the governed AI slashed the code's cyclomatic complexity, which is a measure of how messy and risky software is, by 51%. It took this tangled mess and just simplified the entire system dramatically. And it wasn't just simpler. The code's maintainability index, a score for how easy it is to manage and update, jumped by 7 points. That's a huge deal. It means the new code isn't just better now, it's way more robust and ready for the future. And for anyone who loves the hard data, this table just lays it all out. The lines of code were nearly cut in half. Complexity was down by 51%. Maintainability went up. And look at this.
Coding warnings dropped from 51 down to just 1, a 98% reduction. This was a top-to-bottom professional-grade overhaul.
So, we know it worked. The big question is why? Was it really this new governance structure, or could you maybe get the same result with just a really good prompt? Well, they ran a controlled experiment to find out. So they set up 3 AIs to do the exact same messy refactoring job. The first one was just an unguided AI, totally left to its own devices. The second one got the best possible prompt you could imagine, a massive wall of text with every single rule and piece of background info. And the third one, of course, used the new Dual Helix structure.
And here's how they performed. So, no surprise, the unguided AI did pretty poorly. The one with the giant prompt did better for sure, and the Dual Helix AI scored the highest. But the most interesting thing on this slide isn't just that top score.
The real game changer was consistency. That wobble between a good result and a bad one, the governed AI cut that performance variance by over 50% compared to just using a good prompt. And let's be honest, for professional work, a reliable B+ every single time is infinitely more valuable than a system that gives you an A+ one day and a complete failure the next. And that really brings us to the big takeaway here. If we want AI to be reliable enough for serious, high-stakes work, we have to stop focusing only on making it smarter. It turns out how we manage, structure, and constrain its knowledge is every bit as important as its raw intelligence. This really opens up a whole new way of thinking about building AI systems. It proves that we can build AI agents that are truly reliable. But it also leaves us with one last really big question. If every professional AI needs a rulebook to be effective, who gets to write the rules?